You are alive right now because at some point, one of your ancestors kept living for decades after her body could no longer have children. That should not happen. In the entire animal kingdom, almost nothing survives long past its reproductive window. A chimpanzee, for example, our closest living relative, rarely outlives her fertility by more than a couple of years. But human women can live 30, 40, 50 years past menopause. Evolution is supposed to be ruthless about cutting off investment in bodies that can't reproduce anymore. So why didn't it cut you off? Why did it keep your great-great-great-grandmother around instead? Have you ever thought about how much of your own childhood ran through a grandparent, not just your parents? Tell me in the comments. I'll read them. Here's the parts that should bother you. Menopause looks on paper like a design flaw. Natural selection rewards traits that help you pass on genes. A body that stops being able to reproduce but keeps eating, keeps needing warmth and safety should be a liability, not an asset. Killer whales and humans are among the only species on Earth where females regularly live long past their fertile years. That's it. Out of millions of species, this pattern shows up in almost none of them. So sometime something unusual had to happen in human evolution to make menopause not just survivable, but repeatable, repeatedly, reliably selected for, generation after generation. The explanation researchers keep coming back to is called the grandmother hypothesis, developed most notably by anthropologist Kristen Hawkes, based on decades of field work with Hadza, a hunter-gatherer population in Tanzania. Here's the rehook. If menopause looks like a cost, ask what it's buying instead. Hawkes watched older Hadza women who could no longer bear children spend their days digging tubers, the deep hard to extract root vegetables that young mothers weighed down by nursing infants physically couldn't gather as efficiently. Those grandmothers weren't decorative. They were feeding grandchildren directly, freeing up daughters to have their baby and another baby sooner, safely. One grandmother's foraging output could measurably shorten the birth interval of her own daughter because she was quite literally subsidizing the next pregnancy with food. Now here's where it gets stranger, and this is for the next idea. This isn't just about babies being fed, it's about why your own lifespan is shaped the way it is. Grandmothering, according to this model, didn't just help individual families, it shifted the selection pressure on the entire species' life's history. If other women who could no longer reproduce were still increasing the survival of their grandchildren, then genes that extended healthy lifespan past fertility stopped being useless. They started paying out, generation after generation, in the survival of children who weren't even theirs to bear anymore. Slowly, over hundreds of thousands of years, humans evolved to live long past the point where biology would otherwise expect us to die. If grandmothers were subsidizing food, that changes what a human childhood even looks like compared to every other primate. How children were weaned earlier than chimpanzees, years earlier, but we take far longer to reach food maturity. That combination, early weaning plus a long, slow childhood, is almost unique to humans, and researchers argue it only works because someone else, specifically an older female relative, is there to help provision a child who is no longer nursing but still can't feed themselves. Chimp mothers can't afford that gap. Human mothers backed by grandmothers could. If you had a grandparent who helped raise you, was it more about food and safety or more about emotional stuff? I'm genuinely curious which one people remember more. This isn't settled ancient history either. In 2025, Kristen Hawkes herself published a formal revisiting of her own original 2003 paper on grandmothering and human longevity in the American Journal of Human Biology, checking the hypothesis against more than 2 decades of additional data across primatology, genetics, and demography. Her conclusion held up. Compared to great apes, humans really do show this distinctive package: slower physical development, earlier weaning, and a long postmenopausal lifespan, and grandmothering remains the most consistent explanation tying all three together. A separate 2025 simulation model examining how mother-infant energy demands interact with help from grandmothers and older children found that this kind of support could specifically avert what researchers call a midlife energetic crisis for mothers, adding new mathematical weight to decades-old field theory. So here's the rehook in the close, and the part that should sit with you a little differently now. You did not evolve to die shortly after you stopped being useful for reproduction. You evolved in part because someone else's grandmother didn't. Every extra decade of human life past fertility exists because deep in your ancestry, an older woman's presence made the difference between a grandchild surviving and not. The long life isn't a side effect of modern medicine. Medicine extended it further, but the foundation was laid a very long time before hospitals existed by women whose bodies had already finished having children and who kept mattering anyway. So the next time someone frames aging as decline, as a body becoming less useful, it's worth remembering that your entire species may only exist in its current form because evolution decided the opposite. Value didn't stop at fertility. For humans, it kept going. What do you think made this possible in humans, but almost nowhere else in nature? Let me know in the comments. I do read them.